Hey everybody, it's Dr. Schulman. I'm gonna go over some more geometry. This is 6D, and 6D is pretty much no strategies for using nets and representing three-dimensional figures. Now, I know we've done some of that before, so I wanted to add a piece. So I added a little piece about reflections, lines of reflections and rotations. So I'm going to teach you a little something first before we jump into the nets. I hope that's useful for you. And if you don't like it, guess what? You're gonna just learn some new stuff. So lines of symmetry, lines of reflection, this is great for students of any age. It helps them when they're trying to learn about tessellations, which are just repeated images over and over again. So I'm gonna jump into it. And we will, here we go. I'm gonna share my screen. I'm going to teach you a little something first, and then we're going to jump into the problems because there's not too many, so I added the piece. I'm sure you're like, there's so much already. If you feel like there's too much, I'm sorry. I'll try to chill out. Just want you to be a prepared educator. So here we go. Here's, oops, sorry, that's the quiz. I have not made your quiz yet. I will when I'm done with this. So this is some stuff I'm going to add. Let's start with just some cool superhero logos. So I've made this before. I think it's a really good way to help students understand reflections and rotations and lines of symmetry. So I can draw on it. So if it's a line of reflection, basically all it has to do is when we cut the shape, it matches. So for the X-Men logo, there is 1, 2, 3, 4 ways I can cut this, fold it where it matches. And the rotational order for this logo means how many degrees can I spin this and it looks the same. So I usually put a dot here, have the students trace it and spin it. And this just means as I spin it, it's going to match up once, twice, 3, 4 times. So it has an order of 4. So this means every 90 degrees, it's a match. So let's try one of these. This first one is Bullseye, or no, it's Deadshot. Sorry. Bullseye's logo is just the circle with this in it. I know I'm a comic book nerd. So basically this has 1, 2, 3, 4. It also has 4. So it's rotations, 4 lines of symmetry. It's going to look the same 4 times. So its order is 4 and its angle is 90 degrees. All right. So now we got our girl Black Widow. Oh, that was ugly. So I believe I'll just do the first 3. So here's Black Widow. That's 1, that's 2. Yeah, it's just 2. So it also will only look the same twice as we spin it around. So twice it'll look the same with 360, so 180. And I'll do one more. This is Cap or Captain America. We can split the star once, twice, 3 times, 4 times, and I believe it's 5, right? 1, 2, 1, 2, 3, 4, 5. There it is. Sorry. So we have 5 lines of reflection. So when we have these 5 lines of reflection, this one should be here. That's why. And then if it's also an order of 5. It doesn't always have to be the same. So this is going to be 360 into 5. Is that 72 degrees? Nice. Cool. So that's some basic information. That's 3. The Hulk hand has none, right? So no lines of symmetry for Hulk. But if I spin it all the way around, it will always have everything will always have a rotational order of 1, which basically means it'll turn back itself at 360 degrees. Isn't that fun? So that's 0 and 1. Don't be confused like things like the flash, no matter how you fold the symbol, it's not going to match. So this one also has 0. All right. So I'm sure that was fun with the shapes, but let's do the actual, like we did the logos, but let's do one with the actual shapes. So this is what your students might be faced with, where they actually have to fold these squares or hexagons or spin them. So this means reflection over, I should download it. So this basically means we're doing a reflection. So here we're doing a reflection. Oh, this is the line of reflection. So we're reflecting over line M, and we're starting with E. Now you might think it goes right here, but this is the line we're reflecting over, so it's actually going to land on G. And if we are reflecting over, use a different color. If we are reflecting over line N, which is this one, and we're starting at B, if I fold it over, it lands on H. And you can go backwards as well if you want. Now remember, spinning these things, we always go what? Counterclockwise. So if we're rotating around the origin, we're starting with B and we're going 90 degrees. So this would be 90. This is 180. That's 270. 360 is back to B. So 90 degrees just puts us at H. Let's do a 270. So now we're starting at G. We got to go 270. So ready? 90, 180, 270. So this one's A. Negative goes the other way. So don't be afraid to try these. We reflect over M. We're starting at D. Oh, it's on the line itself. It stays where it is. So feel free to give these a shot, practice, really look at them. This is 60 degrees each instead of 90, but it's the same idea. So try your best. Hopefully that was a good intro. So what are we doing now? We're doing some nets. So basically the nets of each solid, if I fold these up, we get the shape. So so they just want us to do the measurements, but we're actually going to solve them. We're going to solve one of these just because we can. Just because we can. All right, let's do this. We're just gonna round this to be, whoa, sorry. We're gonna round this to be 9. And we're just gonna do the one that looks like kind of like a battle axe. Actually, let's do this one. All right, so basically, if I have a pentagon, we're doing number 4. And I know that the height is 9. And I know that this is 13. There's a triangle right here. And I can count them all the way around. So that's 1 triangle, 2 triangle, 3 triangle, 4 triangle, 5 triangle. It's really 1/2 base times height, but I have how many of them? 5. So it's 5 times 0.5 times 13 times 9. That gives me this whole one. And if I double it times 2, now I have both of them. Now each one of these little rectangles, remember, because it is a pentagonal prism, they're all going to be 8 by 13. And how many do we have? 1, 2, 3, 4, 5. So the other one's length times width times 5. Add them all up. We got the surface area. So let's do it. First one's 8 times 3 times 5, 8 times 13 times 5. So all of these together make 520. All of the rectangles make the 520. And then let's do the big one. So now we have 10, because there's 2 triangles and there's 5 sides and 5 triangles within each. I gotta times it by 0.5. Then I gotta multiply it by 13. And I gotta multiply it by 9. So that's 595. And the other one is 520. We add them up. And this is 1,105 surface area. Same thing here, 2 circles and the rectangle. These, we have these little pieces, 5, 16, and 15, right? So try your best with these if you want to practice with some of them. I think that'd be good to try, especially cutting these up. So I definitely just wanted to show that before we jumped into it, before we jumped into D. D is short, the rest of them are short. We knocked out all the hard ones already, so. We're in D, strategies to represent three-dimensional figures. I just give them the shapes. Either use technology or just bring in the shapes, have them cut them up. It'll be really useful for your students. All right, so let's get the delta. And we are in 6D. Knowing these strategies. Where, see, look, it's short. So we're going to go in for it. So let's identify a prism. We got to do 3 of them. If we're ripping this up, it's got rectangles and we need a top and a bottom. I like C the best, but there's only 3 rectangles. These have 4. All right, 1, 2, 3. So it can't be C or D. Oh, so A. A is the only one with 3. Ta-da. What? Do you only have 3? Did I not count? Oh, yeah, that is the right one because I knew this one was weird. All right, let's do a couple more of these. All right, if we fold this, this one's D. So really practice these. This is a triangular pyramid, square pyramid, prism. Yeah, it's A. So do a couple of them, get into it. Ta-da. Cool. All right, let's do surface area. Outside of a box, triangular pyramid. If all the triangles are equilateral, then what is the surface area of the box? So we have 1, 2, 3, 4. It's 1/2 base times height, and then we have 4 of it. So we can cross this out. So it's just 2 times base times height. Your base is 9, your height is 7.79. 9 times 7.79 times 2. 140.22. That's the surface area. Sweet. So we have 1 triangle, and then we got 4 of them. Let's go harder. So which values represent the dimensions? It's 6 by 16 by 24. What? It is 6 by 16 by 24. Oh, they want the outsides. Okay, I see what they want. All right, let's do another one because I gave you the areas. I thought those were the sides. Oh, I don't care which one they give us. All right, we'll do one of these crazy ones with the question marks. Okay, so 4 times 12 is 48. 12 times A. So the missing face is what? It's got to be 5. The length of the missing edge. Okay, so this is an edge and the face is here. So these are 20 each. Nice. So I did this by saying 12 times what is 60, and then 4 times that number is 20. All right, let's do one more. We just did this one. Okay, so this is going to be 9 by 2 or 6 by 3. So these could be a number of different things, right? I guess that's the hard part, right? So we can do, well, 10 times 18 is 180. There's no 180 here, so this is out. 9 times 10 is 90, that works. 9 times 2 is 18, that works. And then 2 times 10 is 20, perfect. So I just was multiplying the choices to see which match. 9 times 18 is too big. 20 times 90 is too big. So that's how you do it. Ta-da. Nice. All right, let's do another one. So it's dilated by a factor of 5. What is the volume? Okay, so cool. So we know it's 3 by 3 by 8. 3 times 3 times 8. So we know it was originally 72. But the solid is dilated by a factor of 5, which I mean all of these should be up by a factor of 5. So I don't think it's just going to be as simple as 72 times 5 for 360. I think we have to do 3 times 5 times 3 times 5 times 8 times 5. So I think it's 15 times 15 times 40. I think that's going to be the answer. Let's see if that's right. Because each one of them is getting dilated, each side. So we have to account for that fact. So I think it's going to be 9,000 instead of 360. It's much easier if I had the box, but yes, nice. Each one of them had to be brought up. Or we could do 72 times 5 to the third. Ooh, I like that scale factor to the third method. That was way better. I multiplied each of them, but they just did the scale factor of 5 times cubed. Either way, same answer. All right, let's do another surface area one. All right, so that's 4 and 4 and 2. We've done this already. So it's 4 plus, so it's 8, 10 and 2. 8, 10 and 2, it's 20. We already did it, so I did it in my head. What? 28? Oh yeah, it is 28. All right, let's try it again. 4 times 1 is 4 plus times 2 is 8. 24. I actually have to do it. Okay, so I usually do 4 times 2, that's 8. And then I do 6 times 2, that's 12. And then I do 24 times 2, which is 48. It's 68. Guess I couldn't do it in my head. Ta-da. All right, let's keep it going. Here's surface area of a square one. I like it. Oh, let me go over to the side. So find the surface area of a square prism with side length 3 and a slant height. So surface area. So square pyramid. So that's a square. 1, 2, 3, 4. Well, the square is just 3 by 3. So the middle is 9. And then I have 1/2 base times height. And how many do we have? 1, 2, 3, 4. 4 cut in half is 2. The base is 3. And that height is 6. So we know it's going to be 9 for the square plus 1, 2, 3, 4 of these guys, which is 6 times 6 is 36. 45 is the answer. Notice that it's inches squared because it is a surface area. Beautiful. Now I got surface area of a cylinder. So I'm not going to mess this up. 1 circle, 2 circles, so it's pi r squared, but there's 2 of them. Then we have the rectangle, which is 2 pi r times h, and we add that together. The radius is 2. So 2 squared is 4. 4 times 2 is 8. We have 8 pi's. 8 pi's for these two guys. They're 4 pi each. Then we have 2 pi r, so that's 2 times, so this is 4 pi times the height, which is 7. So plus 28 pi's. We can add them. 36 times 3.14. We want to round to the nearest thousand. $113.04. What? Oh, because I didn't do pi. I'm not doing it again. It's because I did 3.14 instead of doing the whole thing. So 36 times pi. Give me a break. 113.097. Get over yourselves. All right, let's do it. Pythagorean theorem. So let's measure IJ. Guess I got to do it again. Measure the length of QR. Here's R. Here's Q. The estimation is 6.123 6.35. I'm assuming they're going to have us do it. Okay, and that's the hypotenuse, so 4.4 squared plus 4.6 squared. We take the square roots. That's why it got wrong the other time. So 4.4 squared plus 4.6 squared equals, then we square root it. How am I so off? The length of QR. 1, 2, 3, 4, 5, 6, and a little bit. All right, I'm trying this again. 4.4 squared. $40.52. Yeah, that's it. Now let's see the square root. Okay. 3 decimal places. 6.366. I don't know. My calculator's weird. It's just the best one for the screen. I could just see that it was off, so. All right, let's do a Pythag with rounding. All right, so here we go. More Pythagorean theorem. I just thought you're going to need a bunch of it. So here's 10. And there, sorry, 10's here. And C is always the one that's opposite this. So don't be afraid to draw the boxes in for your students. So there's your 100. There's your 144. A squared plus B squared equals C squared. All right, so for the next one, I have to already put a new notepad because I can see it's changing. So we have minus 100. So we have 44 is x squared, and we just have to take the square root of 44. 1 to the nearest 10th. 6.6. So here's some Pythagorean theorem. So find the length of the third side. Okay, so this is 58.49. We have 58 minus 49, which is 9, and the square root of 9 is just a lonely 3. No radical needed. Nice. All right, so here we don't have the diagram. So we have the hypotenuse is 10. And you'll get better with this. You'll know that 3, 4, 3, 4, 5, 5, 10, 12. They're like specific Pythagorean theorems that always work out. So the hypotenuse is 10 and one of the lengths 9. So that's x. So we're left with x squared plus 81 equals 100 minus 81 minus 81. So we have, what is that, 19? We just want the square root of 19, which is 4.4. There's the diagram. There's the answer. All right, here's a multi-step one. So we have to solve for x, which is here. So if I cut this, right? Okay, so this is a good problem. It's a composite shape. You'll see tons of these. You always want to make them look as weird as possible. So if I know this whole thing is 10, I'll try to draw it better. Looks like a spike. If I know this whole thing is 10, no, that's 8. So this little piece right here is 2. and this is 1. So we just need the hypotenuse. So it's 1 squared plus 2 squared equals c squared. 1 plus 4 equals c squared. 5 equals c squared. We just take the square root of 5. What a nice tough one with the composite shape. Nice. All right, here's level 2 with multiple steps. Okay, so we got a kite. These are perpendicular. We just need what line? A, C. We need this whole line. But we know because it's a kite. Okay, so I have to do 10, 9, blank, blank, 10, blank. So I have to do the Pythagorean theorem twice. So the first one's going to be 10 squared. Oh, wait. This is 10. So I have to get this one first. So this is 5, 10. So here's the little one. So that's 5 and that's 10. We have 25 plus x squared equals 100. We're going to minus 25 to both sides. X squared equals 75. Square root of 75. So boom, that's your first one. That gives us half. And we just want AC, right? Okay. So this gives us this piece, and then we have to do it on this side for the other one. So the square root of 75 is the first part of our answer, which is 8.66. So we're just going to have to add it to this one. So we know this is 5, and now we have 9. So it's basically the same thing, but now it's 25 plus x squared equals 81. So all we have to do is 81 minus 25. We take the square root of 56. We add this to 8 plus 8.16. And we have 15 points to the nearest 10, 15.6. These little squiggles, this means approximate. What? I got square root of 56. I got square root of 75. 7.4 plus 8.6 is 16. Oh, come on. It's the calculator again. Oh, that's so annoying. I had the right answer. So 56 square root plus 75 square root. Well, I'm not going to question it. It is what it is. I got it right. All right, let's do a word problem. So if you place a 32-foot ladder against the top of a 16, okay, so this is 32 feet. And we know this is 16 feet building. How far does it have to be? So 32 squared, I'm going to take my time, is 1024 minus 16 squared. Oh, I hit square root instead of squared. So 16 squared minus 1024. So we just need the square root of 768. To the nearest tenth of a foot is 27.7. Always know that the hypotenuse has to be across from the biggest angle. So it should be bigger than the other one. It has to be the biggest. Ta-da! We just did the word problem. All right, so now we're going to do some backwards and some other stuff. So let's do this converse. So which of the following cannot represent the three sides of a right triangle? 5, 12, 13 works. 25 plus 1, 44. So the best thing to do is you just work it out, right? 27 squared plus 36 squared. And then all you have to do is take the square root. Oh, that's what was happening. I wasn't hitting equals first. All right, so the first one works. 27 squared plus 36 squared equals, and we take the square root, 45. That one works. 16 squared plus 63 squared equals. Now we take the square root. Okay, so it's the last one. I'm not even going to try it. I trust myself. Boom. Nice. Now we got a level 2 of this. Sides 50, 93, and 87 use the right, acute, or obtuse. Okay, so we just have to see, all right? We have to decide. So here we go. So we know this is it. A squared plus B squared equals C squared. This happens a lot with naming them. So 50 squared plus 87 squared. Is this bigger? Is it less than, bigger than, or equal to 90 squared? That's all you have to do. So let's work it out. So I have 50 squared plus 87 squared equals, so 10,069. And the other side is 90 squared. And this is 81. So these are bigger. So we know it's not a right triangle. Now, if the two smaller sides are bigger than the third side, do you think it's going to be obtuse, acute, or right? Let's say acute is less than the sum. Oh, sorry, is greater than the sum of the, because the square of the largest side is less than. So let's go with acute. Let's see if it works. Ta-da! So it should make sense. So if it's equal, it's right. If the third side is biggest, if it's bigger than that, look, then it's all stretched out. So it's got to be obtuse. But if it's, sorry, it's all stretched out, so it's got to be obtuse. But if it's smaller, it's got to be acute. If it's equal, it's perfect. So that's the best way to think about it. Just really think about this. This will help your students a lot. The two little sides are fine, then there's no way the third side's bigger. All right. Here we have the volume of the oblique cylinder below. That's 7. This is 14. I believe it has to match. So we want to find the volume. Let's see how to do this. I think this one's too hard for you. That's what I thought. 14, boom, boom. We find the height, and then we do the formula. I knew it. I want another crazy one like that. Here we go. Cool. That's what I thought you did. So we have a right angle here. So we know that this is 11, and we know this is 12. So we do need the bottom. So that's 144, 121. We subtract them. We just take the square root of the answer equals, oh, it's 121 equals square root 4.796. And I believe this is the whole base. I believe the base is not 10. I think you subtract it. I just know it's pi r squared times height. Pi r squared times height. And I just think it's 10 plus this piece, or it's a 10 minus this piece. What do you do? Oh, you don't even need the other piece. We just treat it like the height. Okay, let's do a new problem. That's fine. So they give us the height. It's just pi r squared times height. That's it. pi times 8 squared times 9. It always has to be a right angle. 1809.6. All right, well, this one you have to do Pythagoras, and that's the height. Let's do one that has one of these. So it's just length times width times height. So we need this. So it's going to be 11 times 5. So it's 55 times whatever that is. So 169 minus 64. I'm just using Pythagoras to get this side. I do the square root of that. And I multiply this by 5. And then I multiply this by 11 to the nearest 10. So 563.6. I think that's right. Nice. Cool. So always base and height. Always get the bottom area, and then it's got to be perpendicular. All right, so let's do some mapping. So I wanted to have these at the end. I think this will really help the early math, like second grade or something. So can we match these? So that's the whole goal. What is this? This has to be a rotation. A rotation counterclockwise around point X. And then what has the same slope? I would do XR as the same slope as XV. Okay, or we can do WX as the same slope as XR. Well, that's spun around. It's definitely not a rotation. It's definitely a rotation. Oh, because we're going counterclockwise always. So around point X. Okay, so we have to say when they match. Okay, so around point X. We'll have the same slope until I'm like literally touching the screen. I believe Rx. We're moving this around. That's S is here. So I believe XW has to match with SR. Because that's the bottom. I believe XW and SR. WX is the same thing as XW. We want to go to SR. So could it be VW? Wild. This was crazy. VW has to have the same one as SR. Okay. That was tough. Wild. All right, let's do a new one. This is a translation until point. So we're translate. I believe until L matches to O, till O matches to L. Nice. It's got to be the end of it. Wow, these are wild. Let's try one more. This is another translation until point. We go RST, so until T matches to E. That's cool. was hoping for another crazy rotation one because it's blowing my mind. All right, well, we can do the reflection one. So it's a reflection over line JI. Oh, and that's all we needed? Nice. Can we try one more rotation? Okay, here we go. Here's a rotation. We're gonna go, so we start with UVW. UVW. That UVW matches onto this. So we're rotating around point V until UVW. So it keeps spinning, 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 spinning. UVW, I believe WU and KJ. WU and I'm going KJ. All right, figured it out. These were great, great problems. So I added these in just for fun. All right, here's another one. So reflect over RW. Oh, we're doing this one first. So VT. All right, and then we have to translate until point T matches to R. So you can try these yourself. Hopefully they make sense. Hopefully you can start watching them move. I think it'd be really cool. Nice. Oh, they translated first. All right, I wanted to really show you these. So here we go. No, that's not going to look the same when you spin it. Okay, won't look the same until you go all the way around. I'm going to give you a couple of these just because I think they're useful. I'll do 3 of each. 3 of these. 3 of these, and we'll do 3 of the lines of symmetry ones. So we're up to the end, right? I want to do a couple of them. It has, and we're talking 120 degrees, 120. Oh, wait, the smallest that matches was, yeah, 120. Because it spins 3 times and then it matches. All right, let's do one more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I believe it's 10. So 360 divided by 10 is 36 degrees for it to match. Let's see. Oh, that looked cool. Do it again. Nice. Crazy. All right, so have fun with those. And then here's some lines of symmetry. My eyes are so bad at these. Okay, oh no, there's some more. Ta-da! Nice. As you can see, my lines are always going to be a little off because of the blindness. Cool. So try these, have fun with it. How close was I? Ooh, pretty bad. I'm not even gonna try that shape. All right, so here we go. 1. Okay, so here we go. I know this is the coordinate plane, but I just want to show you it. So which transformation? So if I fold this, spin this, where's it going to look itself? So if I rotate it 180 degrees around the point 2, -3, that looks like right in the center. Nope. If I reflect it over y equals -3, I think it's going to match. If I reflect it over x equals -2, I think it's going to match. So I think it's this one. A 90-degree spin won't make it work. So if I spin it 90 degrees, it doesn't fall on itself. All the other ones, you can see match. Every single one of these other ones will match right onto itself. Cool. So that's a good problem. And now we have one more. So which regular polygon is to be rotated about its center? The regular polygons. Okay, so when does it look the same? It looks the same at 180, 90, 180, 270, 360. All right, let's do one more of these because it's a square. A certain polygon is rotated 30 degrees about its center. I'm going to go with a decagon because it has 10 lines of symmetry. 36, yeah. Oh, we want which one's 30 degrees? Oh, it's the hexagon? No, which one is it? Oh, it's decagon. Oh, because decagon was 36. All right, let's try another one. Octagon is 8. So let's divide it by 8. 45. So let's keep going. 45 times 3. It's 135. That's what I thought it was. Nice. All right, so try your best with these. I hope they were useful, and I hope the little lessons in the beginning helped as well. And if you have questions, just reach out.